This is the third rule. It's called the power of a power. In the past, we had two bases with exponents on them. The power of a power rule deals with one base that has two exponents. Like, here's an example. If I take this one base x and it's squared, but then I take the whole thing to the fourth power, that means it has two powers or two exponents. In this case, a power to a power, I multiply the exponents. Okay, here it is with a negative, which is really good for you to see. The negative is in parentheses and it's taken to the third power, but then all of that is taken to the fifth power. So you're going to take the same base, multiply the exponents, and take -3 to the 15th power. Okay? Again, here's an example with fractions. One base, two exponents. You multiply the exponents. Okay? And then we had some exponent identities up here. I'm going to try to watch and see if anybody comes in. Hang on. Need to get it up here so I can see it. Then the other part of my notes for the day that it was, we had blackouts. Last 2 days, I apologize about that. Okay, well, I guess I couldn't do anything about the blackouts. Here are some exponent identities right here. So this is one thing you need to keep in mind here, that anything to the 0 power, anything that has an exponent of 0 will come out to be 1. You're welcome to prove that on your calculator, but anything you take to the 0 power will be 1. In college, in my college math class, our professor was trying to get that over to us, and we had a extra credit point on one of our exams, and he put the word menu, MENU, in parentheses, and he took it to the 0 power and asked us what that was equal to. And the answer was supposed to be 1. Anything to the 0 power will be 1. Okay, now a number to the first power, if you see a number, and most of the time you will, I am so sorry. You'll see a number like this, just 5 or -17 or whatever. If you see one of these, we have found out in our studies that 1 is kind of an invisible little critter that shows up everywhere. And so if you see a 5 and it doesn't have an exponent, it's an invisible 1. And in the same way, if you have some number or some base to the first power, it will always be equal to itself. Okay, anything to the first power is itself. And the last identity right here is if you have 1 to any power, it does not matter. Here are your examples. 1 to any power will still be 1, because if you'll notice here, 1 to the 36th power means 1 times 1 times 1 times 1 times 1 times 1 to the 36 ones. But 1 times 1 is 1, times 1 is 1, times 1 is 1, times 1 is 1. So even over here to the 384th power, it's still going to be 1, because it's 1 times 1 times 1 times 1. Any questions on those?
No.
Okay, Sandra, I hear that. And I know, Sherry, that you're on mute. Are you okay with those rules?
Yes, ma'am.
And you did get those printouts. You just hadn't got a chance to look at them, right?
The rules that I got them in the text.
Okay.
I'm gonna have to send them to my email so I can print them off. But I wrote them as you went over it.
That sounds fine, or I don't mind sending those to you in your email also.
Okay.
Okay, now on the other, I made this other page out because I looked in your packet one that we were supposed to be working on, and I realized that I didn't cover the part that says, this is the exact instructions that they give you. It says express each numeral as a product of power of primes. And these questions are on your workbook pages, or your worksheet pages 5 and 6. So to do this, we're going to use what we call a factor tree. And you're going to be using this very soon when we simplify radicals. You'll be using the same idea. So make sure that you understand a factor tree. Now the 288, you can break that down to 2 times 144. Now, some of you may want to divide this by 4 first, or a larger number, okay, maybe by 16 first. It doesn't matter how you start this tree. But what will happen, no matter how you start the tree, by the time you get to the bottom where all the primes are circled, let me find it, where there's nothing left on the bottom except for circled things, those are primes, then you're finished. And your primes, no matter how you started with the 288, your primes should all match. You should have 5 2s and 2 3s by the end. Now, looking at the factor tree, this is what they want to see. They want to see that it took 2 times 2 times 2 times 2 times 2 times 3 times 3. So I wrote those down. And then what they're asking is, they said, express each numeral as a product of the powers. Powers are exponents. So they want you to take this long strip right here and put it into exponents, which means I multiplied the 2 5 times and the 3 2 times. That's what they want to see, this circled part. Okay, now, if there aren't any questions, well, I'm asking if there are questions because I want to move on to negative exponents, and I have a stupid story for that. But I need to know about some questions.
I think I'm good.
Okay, Sherry?
So the ones that has like the standard form that has the great big numbers, just do like the number tree on those. Is that what they usually do?
The standard form means what is the answer after you did the actual math? Like for example, if your question is 2 to the 5th power, then the expanded form is going to be 2 times 2 times 2 times 2 times 2. But then the standard form will be, what is that equal to? And that would be 32.
Okay. So on this paper here, it says standard form and
Do you know what page that is? That would help me.
page 4.
All right. Yes, that's the one I'm talking about. Let's.
Yes. Okay. So the top part, I didn't have any problem with.
All right.
But when I got down to like B, in the end box where we were supposed to fill that out, I wasn't quite sure how to do it.
You're talking about this right here.
Yes, and so some of them I could take the base and divide it into the standard form. One of them gave me the right answer, but the rest of them I'm like, I don't really know, and so I kind of guessed it, and I come up with the right answer, but I guessed at it, so I really wasn't sure what to do. You know what I'm saying?
In this case, I think they are introducing this to you. And so since the base is going to be 5, we have to find out how many times 5 is going to be taken times itself. So you can use your calculator and just start doing 5 times 5 times 5 times 5 times 5 until you get this number, or better yet, take the 5 and just guess 5 to the 4th power, 5 to the 7th power, 5 to the 5th power, and see which one works.
Yeah, that's kind of what I did.
Okay.
And so, but I thought maybe I was cheating myself.
No, I think this is a place where they're trying to introduce this to you. Now, when you do number 2, remember that -6 needs to be in parentheses when you do that.
Okay, yes, I did all of them in parentheses.
Oh,
Because I
good.
remembered what you said about if we would do them all in parentheses, we wouldn't have to remember which ones had to be in parentheses and which ones not. So
You are-
all the
You are correct. You're
all the
absolutely correct. I love that you listened to me.
okay, so the end part of that paper, the
Yes.
bottom part, I didn't
Yes.
do that one. I wasn't sure, so I left it.
Use the
I didn't
factor
do-
tree.
Okay,
Prime factorization, where they're talking about right here, prime factorization,
yes,
that's the factor tree.
okay,
So if you will do what I just showed you about the factor tree, then you'll be good there. Okay?
okay, okay. So just start with the smallest numbers that equal 32 and work it. No.
Yeah. Now 32 is a really good example here. So what I was saying, you can start out with 2 times 16 if you want to, but somebody else might start out 4 times 8. And that's fine also, because this 4 over here will break down to 2 and 2. And then the 16 will break down to 2 and 8, or 4 and 4. But you keep breaking down the composite numbers until you have all primes at the bottom.
Okay,
Okay? It doesn't matter how you start, but how each one of you ends should be exactly the same.
okay.
Okay. More questions?
Does she not have any questions?
Sandra had said, I think she's okay, right, Sandra?
Yes, I'm okay.
Okay, well, page. I guess I missed writing the number on this page. It's the exponents quotient rule page.
Exponent product rule?
No, it says quotient rule.
Quotient rule. I missed what you said. All right.
Okay, so it's in part B.
Okay.
Okay, so I got the answer to number 4, but I really wasn't sure about it. And
Now,
so I was
there are 2 of those pages. Would you look at the top and tell me if it says T1 or T2?
T2.
All right. Okay. Now I'm on the right one.
So
Number 4, you said on B.
Yes, 4 and 5. 4, I was thinking that they wanted it was like the same number as the base, and I didn't understand that.
Yes, there are 2 of them, and I'm glad you reminded me of that. There are 2 different ones. There's one earlier on the product rule also. Let me get a pencil. Okay, I think what I would like to do is go back to the product rule one, and then I'll come back to that. It'll make more sense. Okay.
Okay.
It
And
is on page, oh, it was the one Luanny, yeah, page 8, that Luanny asked me about earlier on. Page 8, it says exponents product rule, and the problem says, I'm just going to write it down for you because I'm going to show you the work.
okay.
When I just glanced at it, I thought, oh, good heavens, that must be a typo, but it's not. It's this one. It's number 2 on page 8, if you number.
Oh yeah, I had that one. I had that one marked off to ask about
Because
too.
it has 2 variables, and that When I very first looked at it, I thought, why did they throw that one in? Good heavens. Well, it's because they know how smart we are. And so they know that we can handle this. I'm looking for a pencil that actually has an eraser on it. All right. So what you're going to do is draw your line down through the equal sign, okay? And we're going to circle the x because it says solve for x. So here's where I am. I'm going to take you step by step. Here's where I am. Now, if we want to solve for x, then I need to get rid of that b to the -7th, right?
Yes.
So since it's multiplied to the x, I'm going to divide both sides by b to the -7th, okay?
Okay.
Divide both sides by b to the -7th. And it should look like this.
Okay.
So of course the b to the -7ths on the left-hand side cancel out. And we're left with x to the 28th equals. And I'll show you that. This is what you should have. X to the 28th, and if we have same bases on the right-hand side, the b's are the same, and they're divided, so that means we have to subtract our exponents, okay?
Okay.
So we have 21 minus, but then you need to also use the -7. So that's going to turn into 21 plus 7. Do you see it?
Yes. So to be 28.
Yes. Okay. So b to the 28th equals x to the 28th. Now we haven't done this part where you find the square root of both sides, but I want you to just use common sense here. If I have a number to the 28th power equal to a number to the 28th power, it looks to me like the x and the b are exactly the same numbers. Do you see?
Yes.
So in this case, x equals b. We'll learn how to do that using the root later. But in this case, because they're both to the 28th power, then the bases have to be equal. And so x is equal to b. And Luanny, this was one of the things that I sent to you earlier, but I don't know if you received when you asked about this. Are you there, Luanny?
You gotta make her pass out.
Are you about to pass out, Sherry?
No.
Okay. She probably had to go do something. She'll come right back.
I probably will when I start doing them
Because
crimes and them factories.
Luanny doesn't miss. She doesn't miss us. Okay. So I told you from that I would go to the quotient sheet. And this is the same idea. So if you number your pages, we're on number 10 or page 10, number 4 on the second section, the B section. I'll write the question down. And it's the same idea here. I haven't worked this one yet, but I know it's the same idea. 2.5 to the 11th power equals -2.5 to the -7 power. Okay, it's this problem. So if y'all don't have a worksheet, this is the problem we're working right now. I'll give you a chance to write it down. Those of you on YouTube can pause it. Okay, what we're going to do is draw a line down through the equal sign, circle the variable that we're solving for, and they said we're solving for x. I bet y'all thought I was crazy when I told you to draw a line down through the equal sign when we first started. I bet you did. Okay, if we're solving for x, then we know that we want to get rid of this thing that's on the bottom because I need the x by itself, okay? So since this thing on the bottom is divided by, that means to get rid of it, I must multiply by the same thing. So I'll show you what that looks like. Okay, if you'll notice, here on this side, to get rid of this, I have to multiply it by the same thing. So these, the top and the bottom, the numerator and the denominator will cancel each other out, and I'll be left with an x to the fourth on this side. On this side, we've got two bases that are exactly the same. This is where the product rule comes in. Since they're multiplied in their same bases, we simply add the exponents. So this is what it's going to look like. Yes, ma'am, Luanny.
I got my sound went out, so I got off, and I'm trying to get back
Oh.
on.
I am so sorry. I missed that.
It was like real muffled, and I couldn't understand anything.
Okay, I knew that you didn't just bail on us.
It's still doing that, so I don't know.
It's still doing the funny sound.
Can you hear it?
It's a very
It's muffled. I'm gonna try to switch it to Bluetooth, I guess.
okay. And just holler at me again if you go out again and I'm missing you, okay?
Okay.
Okay. And this is what this looks like now. We canceled out the negative 2.5s on the left-hand side, and we're left with an x to the fourth. And then over on the right-hand side, we have same bases, and we add the exponents. And so now we have x to the fourth is equal to negative 2.5, and negative 7 plus 11 is 4. And again, if you notice, both of the sides have a number to the fourth power. Well, if both of them are to the fourth power, then the bases surely need to be equal to each other. Okay? And so in this case, x is going to equal negative 2.5. Does that help, Sherry?
Yes, ma'am.
Good, good, good. And Sandra, you're okay with these?
Yes, ma'am.
Okay. Let's move on to negative exponents. And I can teach you like a technical way to figure out negative exponents. Let me say this first. The negative on an exponent has nothing to do with negative numbers. If there is a negative sign on an exponent, it simply is a code to tell you that whatever has the negative exponent has to move. Okay, you'll understand a little bit more here in just a minute. Just understand. Luannie, are you hearing me any better? I can see you, but our wireless with you, I think, is very delayed because your picture is kind of jumpy and delayed. It could be just the weather with your internet. Do you think you can understand me, maybe? Right now you're muted. I can't hear you. Okay, are you able to hear me, or is it still, okay. I can't hear you. Okay, I understand that you're using your Bluetooth now, but the speaker for some reason is not working, so I can't hear you. So either call me if you have a question, or you can put something in the chat. I might see it. I'm not very good at watching the chat. Okay? All right. Now the negative exponents, one more time. A negative on an exponent has nothing to do with the number or the base being negative. A number on the exponent is simply a code that tells you that that base needs to be moved. But I found out the easiest way that all of my students catch on to negative exponents is to give you a real silly scenario. So I'm going to write it out real quick and I will explain my silly story. All right. Now I need you to imagine, remember this is a silly story, has nothing to do with proper mathematics, but I think it's the easiest way to understand a negative exponent, okay? Now just imagine you are the landlord of an apartment building, and this apartment building just has 2 stories. Now, one of those stories isn't better than the other. There's just the first floor and the second floor. That's it. Okay. Now, besides being the landlord of this two-story apartment building, you are a very fair landlord and you are a very efficient landlord. So you have a little book. We won't call it a black book, but you have a little book that has all of your tenants' names in it. And during the month, you keep little notes for yourself. Like if the other apartment owners are complaining about the music being too loud, you make a note of that, you know. And if somebody is so good on paying their bills on time, they pay their rent, they're no trouble, you keep a note on that too, okay? Now, put yourself in the place of that landlord, and it's the end of the month. Now, at the end of the month, you go to each one of your tenants' doors and you discuss with them, and of course, collect the rent, but you discuss with them what you have written down in your book. Some of the tenants will have good reports. Some of them will have not so good reports. Okay. Now, if they have a good report, they're welcome to stay right where they are because everything's working. If they have a not so good report, you're very fair and you want to give them another chance. And so you tell them what the problems are, and I will help you pack up and let's try you in an apartment on the different floor. Let's try you again on a different floor. Maybe that'll make a difference. And when I do help you get moved, when you move to that other floor, I am wiping out your bad report. You don't have a bad report anymore. We're going to start clean. Okay. So do you all understand the scenario? And then I'm going to show you the math that goes with it. Everybody understand? You're that fair person. Okay, it's the end of the month and you're going to talk to your tenants. So here is an example. And each one of these, A is one of your tenants, B is one of your tenants, C, D. So right now you have 8 people living in your apartment building. Now the exponents are their reports. Okay. These are the things that I've written down during the month. And so you can see some of them have good reports, some of them not so good. This is a negative report. So we're going door to door. Here we go. So when I go, I'm trying to put this so it doesn't wiggle. So I'm going to A's door. And when I go to talk to him, I say, you know, look, there's a few things that I think you need to get better at. And so I'm going to try you on the other floor. But understand, then all the records are wiped clean. And he says, oh, good. Thank you so much for my new start. And so A, with his report, is going to move to the first floor. This looks like this. And when he has moved to the first floor, we took his negative report off. Do you see? He moved from the first floor that wasn't so good to the second, or from the second floor to the first floor. Anyhow, he changed floors. So then I went to B and I said, everything looks good. Do you like where you are? Yeah, I like where I am. So you get to stay where you are. So B to the third is going to get to stay right where he is. No moving, and moving is not a fun thing to do. And so now B to the third gets to stay here. Now we come to C and I don't see a report. But we talked a little bit ago, if something does not have an exponent, what is the exponent? Talk to me.
I don't know, because I missed that, I think.
Okay.
Would it be 1?
Yes, good job. It's going to be 1. Everybody in your apartment building has a report. Everybody has an exponent. And so you can put a 1 on his, and it's a positive 1 because we didn't have any negative anything. So he gets to stay right where he is. He likes it. He's going to stay. So tell me what I'm going to do with a D. I don't know what I'm going to do with a D.
You're going to switch D to the bottom also.
He's going to move to the bottom, and when he does, what's going to happen to his report?
It goes away.
Good. And so now D is on the bottom, or the first floor. It doesn't mean he's demoted. It just means he goes to the bottom, the first floor. Now let's look at the first floor people. What is the exponent on the X?
1.
1 again. And since it's a positive 1, he likes it right there. What about y?
He needs to move.
He needs to move, and the only place he can move is to the other floor. Okay, so I'll put X and Y where they belong and let you look at that. Y moved, and now he doesn't have a negative exponent anymore. Tell me where to put Z.
On the top?
Z to the 6th. Does he have a negative report?
Oh, no. He goes on the bottom.
Yes, he's just fine where he is. What about K?
It's gonna move.
He's going to move. He has to go to the other floor. So the last two, the Z and the K, I'll put them in. So this is a way, this is the way that you change negative exponents. You're going to see from here on out that we're going to require you to give the answer with no negative exponents. So now you know that if you have a negative exponent, he's going to have to move. The negative exponent has nothing to do with the fact that the base will be negative. Okay? I don't know if you guys want to write this down as an example, but I want to show you something that might confuse you later. Does everybody have down what they want?
Yes.
Okay. So let's say that you have this problem right here. They give you this problem and they tell you to write it without any negative exponents. Well, we know that the negative on the exponent is just a code that says we have to move. This negative stays with the 3. The negative 3 is the base, and it doesn't change because of this. So here's how you're going to work this. The problem here is that there's not 2 stories in this apartment building. So if you find that you just have one number that you have to deal with, then you need 2 stories in your apartment building. Any number can be changed to a 2-story building or to a fraction by putting it over 1. So always remember, if you have a negative exponent to deal with, you need 2 stories in your apartment building. So now, when we went to talk to -3, we told him, we better go to the other floor, okay? And we're going to take the negative off your report. And so the answer to this problem this is the almost answer. But what if there's nothing on the top? Well, you've got to remember that the landlord is always around, okay? And the landlord in this case is our 1. There always has to be somebody on the 2nd floor, always. And so this would be your answer. Notice that the negative on the 3 did not change. Only the report, the negative on the exponent, was a code that says to move. That's all. Is this relatively clear?
Yes.
Okay, let's go to some of those and see, actually work those problems. So if you number your pages, let's look at
Deborah, is that the packet that I don't have?
It's a still packet 1. It's the one that has the law of the exponents on the front.
Mhm. Because the ones that I printed out, the ones that you had sent me, don't have any of that stuff. It just has the adding and subtracting the radical expressions and the prime factor trees.
Radical expressions, you have that one?
Yes.
Me. I don't think you're supposed to have that. Okay, sorry, sweetie. I will go back as soon as I get off of here and send you the correct packet.
Okay.
This one should have started out with the laws of exponents. That one is, yeah, that should have been the first page.
Okay.
And then we went through bases and exponents and standard form and the product rule and the quotient rule and the power of a power rule. I don't know how your radical thing got in there. I apologize. I will get you taken care of as soon as we get off, okay?
Okay.
All right. Let's look. The rest of you, we should, okay, go to page 15. And page 15 looks like this. Exponents worksheet. And everything on here has a whole number that has a negative exponent. It says solve, but what it means is to write this without negative exponents. And then if you can solve it in standard form, give the answer, then do it. So let's work a few of these. Number 1. 1A, sorry. 1A says 7 to the negative first. Seven to the negative first. Okay? And so the first thing you see there is that there's a negative exponent, and we found out with the negative exponent, you need 2 stories in your apartment building. So immediately, because you see a negative exponent, you make sure that you have 2 stories. It'll make it so much easier to work. Now it's equal to 7 has a negative report, so we have to move him to the bottom. The landlord is always on top. Is there any question on where this came from?
No.
Okay. And then it says solve, which means they want you to move on and tell you what that actually is equal to. And 7 to the first power is what?
7.
7 to the first power is equal to?
Is it 7?
Yes.
Or- Okay.
7 to the first power. And so your final answer would be over here, right here. Okay, because 7 to the first tells us how we moved it, but then 7 to the first power, we want to actually tell what it is. Let me find another one that makes more sense. How about 2B? I saw somebody coming in just a minute ago, and there they are, but I'm not sure who you are. JWLAT. I haven't seen that before.
Oh, that's my new laptop. It didn't fix my name right.
And that is who?
It's Rachel.
Rachel. Okay. All right.
Yeah.
Well, nice to see you. And you've missed some pretty important stuff. So be
I
sure.
know. I watched the YouTube's videos last night, but I only seen the Monday.
We
I
didn't
didn't-
have one on Tuesday or Wednesday because of the blackouts.
Oh, okay.
And so we're back today. Okay. We did a little bit of review on exponents, and then I explained negative exponents, but we're past that explanation and you need it. You have to have it, okay?
Okay.
So make sure that you go back and watch today's YouTube.
Okay.
Okay.
Yeah, I got down some of it.
Okay. 2b on that same page is 6 to the negative 2. Now, what should go through your head is, a negative exponent. I need 2 stories on my apartment building. So let's put a 1 down so that now I have 2 stories. Now I know when I went to talk to 6, I've got to move him to another floor and see if it'll work out there. So I'm going to move him to the first floor, but I'm going to wipe out his negative report. And the landlord is always on top. We need to have something on top. So here is the way we adjusted our negative exponent. But when it says to solve, apparently it wants you to go farther. And so we find out that 6 squared is 36. And so our final answer for this worksheet will be 1 over 36. Should be okay here. Are you all understanding this?
Yes.
Yeah. Yes.
Now I have 1. How about 0 to the 78th power? Y'all using your calculators to find that? It's not a negative exponent, so we don't have to move anything. But remember, zeros and ones act really crazy. I'm going to double check in my calculator and take 0 to the power of 78. Good.
0.
Yes, it's going to be 0 because this means 0 times 0 times 0 times 0 times 0, 78 times. But 0 times 0 is 0, times 0 is 0, times 0 is 0. So 0 to any power is going to be 0. Now that was page 15, if you number. I want to look at page 16 because this also deals with negatives. I mean fractions with negative exponents. So I want to look at 1b on page 16. Oh, Rachel, it changed your name. That's interesting.
Yeah, I fixed it. I was clicked on it and I seen I
Oh.
could change it. I
Okay.
got me a new laptop.
I'm really happy for you. All right. This is
What is-
1b, and it's on page 16.
What is it called? I didn't number my page.
It is.
Oh, okay. I'd done that one.
And I'm doing this 1b right
1B.
here. This one.
Okay. All
Now,
right,
the
I
one
got
thing
it.
that you guys need to know, this works with exponents. If the exponent is on a fraction, but it's in parentheses, that means that you can split this up and put this -2 on both pieces, like this. This is legal to do. You put the -2 on each piece because the -2 is on the parentheses. So it says do the -2 on everything. So we have our 2 stories and negative exponents. This is our apartment building. So we go talk to 6 and we have to move him to the other floor and take his negative off. And the 7 also is not doing so good either where he is. So we're going to move him also
Oh, you just flipped them.
But don't remember it as just flip. Be sure and look at the YouTube, okay?
Okay.
As if you say, oh, I just flipped. Yeah, you kind of do, but you need to remember why, okay?
Alrighty.
I mean, why in our stupid story, anyway. Okay, and then this page again says solve, and if you can find out what 7 squared is, which is 49, and what 6 squared is, which is 36, then the final answer they're going to want is this one, where it says solve. Now this right here is called the standard form. This one is exponential form because it has exponents. This is the standard form where it doesn't have the exponents anymore. Any questions?
No.
I did those papers wrong. I thought because I didn't get my papers numbered, and when I went back to number them, my internet was messing up. So I couldn't get them numbered. And I said, well, maybe that paper must have been at the very beginning, and she wants us to practice putting these things in parentheses. So I put all of them in parentheses and did them in the calculator.
Oh, okay. Well, I'd like for you to go back and do it this way again, okay? Because
Okay.
there will be times that you can't do it that way. Now, that was pretty smart, girly, okay? You did the best you knew, mathematically correct, because you got the right answer, didn't you?
Yes, ma'am. I said, this is easy.
I just need you to understand what's happening with
Okay.
negative exponents, okay?
Okay.
So if you would go back and try that again, that would be great.
Okay.
Okay. The negative exponents were all, I wanted to do a review today, and then the negative exponents. The last page, page 19. Keep mine in order, just a minute. Okay, page 19. Looks scary. Don't be scared. Okay, like, let's look at number 2. Number 2 right here. The first thing you're going to do on this is to, you see a negative exponent, not the -2, but a -3. The negative exponent says, oh dear, that guy's going to have to move. So the first thing that I would like for you to do on that number 2 would look like this. Since he is already in an apartment, it already has 2 floors. Oh, Deborah, I messed that up. Not true. Ah, 6 squared was okay, wasn't he? So he stays on the bottom, and -2 to the third moved to the bottom. So now what you're going to do is use your calculator to find out what 6 squared is, and then what -2 cubed is. I'll write that down for you while you find out. Should look like this, because 6 squared, wherever it is, right there, is 36. -2 cubed is -8. That 3 isn't cubed, that's number 3. And so the last thing you would do here is to multiply these two. So your answer should come out -1/288, because the negative on the fraction can go anywhere. Do you see what they're wanting you to do?
Yes.
Okay.
Let's go to number 5 real quick. Okay. Number 5, you need to do all these separately. Now, my first inclination was to do this, but it is wrong. That's why I'm not going to write it very light. I mean, very dark. When you see that negative exponent, your first inclination is, she said, put it over 1. However, moving the things up and down in the apartment building doesn't work if you have plus and minuses. So what you're going to have to do here is, if it has plus and minuses, you only change the one with the negative exponent, like this. So what you're going to end up with is 1/4 plus 9, positive 9, minus 36, 216, I think. 6 to the 3rd. Yep. So the 2 to the -2/1 flips the 2 squared to the bottom, and 2 squared is 4. Plus the -3 squared becomes a positive 9. And 6 cubed is 216. And then you just put that in your calculator. It'll come out kind of ugly, but that's okay. When you use your calculator and turn it back to a fraction, this is where you are. So when it's pluses and minuses, you're going to have to do each of the powers separately. When it's multiplied, then you can use your two-story building. So before tomorrow, try some of these, and we'll see how it works tomorrow. I don't know if we're going to be in the classroom or not.
It's snowing again outside.
Yeah, it's been snowing out here. Of course, it's dry and not really thick right now. It's just kind of floating around, but it's been going since I got up this morning.
I know, it's like, go away already.
That's how I feel here.
I kind of like it, but
Yeah,
I'm
but
a mountain person. I know. Being stuck at home, I'm starting to get cabin fever, but besides that, I think it's awfully pretty if I don't have to be out in it.
yeah, me too, but I prefer to be in class.
Yeah, I like to see you guys face to face. So, what do you think?
Well,
Hard.
Okay, Sandra, I'm going to send you the whole packet again just to make sure you get the correct one. And I think the 0 packet just had squaring numbers. Did you get that one fine?
No. I think those are the ones that you had told me you had them in the classroom for me.
Oh, this is true.
So
And we
I
never have gone to the
yeah.
and we haven't gone to the classroom. Okay.
Mhm.
I'll send both of them to you today.
Okay.
Is anybody else missing some pages, or you're kind of confused because I refer to something that you don't have?
I got it.
That's the packet, Rachel, that we're working in right now. And we've been through all the pages now. So I need you to just give it a shot and mark the ones that you're having trouble on. You can text me pictures of the ones that you're having trouble on. Luanny and I have been sending pictures back and forth whenever we can get them.
I
Right.
did this one after watching the video,
Okay.
and I had got those right. Now I'm working on packet one, kind
Very
of like jumping through it on the ones that I can figure out to do.
Very good. Very good. Well, you can get in touch with me by text, by email. You can call me. Okay. Whatever you guys need to do, I try to check it several times a day, pretty often. Okay.
Alrighty.
Okay.
Do you think you have enough to start with today?
Who?
Everybody.
Yes.
I'll watch the YouTube videos.
Yes, you need to do that, especially today. You missed a lot
Yeah, I
of
was
important
going to
stuff.
try to get on earlier, but my daughter didn't want to go to bed on time, so I got stuck with her up. And then my husband got sick yesterday,